Hey everybody, it's Mr. N, and we are going to cover the inverse functions, namely the derivative of an inverse. So an inverse function, f inverse, is what we already know, and we say f to the negative 1, which means the inverse. And a function is called one-to-one if it never takes on the same value twice. So we're doing a little bit of review here, one-to-one. So in other words, if I've got these inputs and these outputs, right here, in and out. For every input, there's only one output. And that's in baby words what that means, and that's one-to-one. So remember, a function has to pass a vertical line test, and it's okay if it's not one-to-one. It can still be a function, but it has to pass this test, and you cannot have an input branching out to two outputs. So I cannot have, like, say I have 1, 2, 3. I can't have this 1 coming over here to two different outputs, like say 5 and 6. It can't go to 2. However, you can have two different inputs go to the same output. So you can have 4, 2, and 4, say both of these go to 5. Okay, that's okay. Now think of this in a vertical line manner. If I had a parabola, right, here's an x value. So suppose this input was 2 and this input was negative 2. They're going to have the same y value up here. So that's okay. You can have two different inputs going to the same output, but you can't have two different outputs going to the same input. That would be this parabola that goes sideways, and that does not pass the vertical line test. But for one-to-one, every input has to have a specific output. Nothing branches out, nothing collapses in. So now the horizontal line test is what we use to determine if it is one-to-one. So if and only if the horizontal line intersects the graph more than once, so if it intersects it more than once, then it would not be one-to-one. So for something to be one-to-one, it needs to pass both the vertical and horizontal line test. So is this parabola one-to-one? No, because if I do the horizontal line test and come through right here and go like this, it crosses it in two spots, so it does not pass it, so it is not one-to-one. Is it a function though? Yes, it is. All right, moving on. Inverse, I'm kind of going through this fast because you should know these. Inverse, so an inverse function, let f be a one-to-one function with domain A and range B. The inverse has a domain B and range A. So basically these inputs and outputs, what you learned, so we have in and we have out. For the inverse, we're going to switch the ins and outs, right? So f inverse right here of y equals x if and only if f of x equals y for any y in b. So basically, we're switching the x and y. So the inverse of x equals y if and only if f of y equals x. So f inverse of f of x equals x, right? The inverse of itself is x for every x in a, and f of the inverse equals x for every x in b. So basically, to find the inverse, we just switch x and y and solve for y. So here is our example. Find the inverse right here, and I did it for you. Switch the x and y, so right, f of x is y. So I switched it, I put the x here, put the y there, and now I solve for it, and that's my inverse function. What does all this mean visually? Well, here's what it means visually. It's me taking a graph, such as this, and reflecting it about the line y equals x. There's my line equals x. I reflected about the line, and that's the inverse of it right there. So that is what visually the inverse means. So we have this theorem. If f is one-to-one continuous function defined on an interval, then its inverse is also continuous. So as long as the function is continuous and one-to-one, the inverse will be as well. So here's what we're going to do with all this. We are going to apply this to be able to find what's called the inverse derivative, because sometimes a direct brute method won't help you, so we have to come up with another way, and this is the other way. So right here, if f is a one-to-one differentiable function with inverse, f inverse, and f prime, the inverse of a, doesn't equal 0, then the inverse function is differentiable, and that's because it's one-to-one, and that's because of that. Right here, here's our formula. To find the derivative of an inverse. We're just going to take 1 over, we're going to find the inverse, and we're going to plug it into the derivative. So be careful what this means. This means 1 over, we're going to find what the inverse is at some value, and then plug that value into the derivative. That's all you got to do. You don't have to switch the x. You will have to switch the x and y and solve, but it's a little bit different process. So let's take a look at how we're going to do this first one. And I'm going to do this first one in 2 methods. Method 1 is going to be like the brute force method, the direct method. And then method 2 will be using my formula. So here's method 1. We're going to write method 1, and this is going to be directly. Okay, and here's how we're going to do this. First thing, how do I find the inverse? To find the inverse, right, I need to switch the x and y. So this problem tells me that f of x equals the square root of x. I need to find the inverse at 1, the derivative of the inverse at 1, I should say, and the derivative of the inverse at 9. So in my direct method, let's go ahead and first find the inverse, right, because I'm finding the derivative of the inverse. So to get the inverse, I have x equals root y. I switch the x and y. So I end up with x squared equals y. So that means the inverse of x equals x squared. So now I'm going to take this and I'm going to take the inverse of x, the derivative of this, right here, and I'll get 2x. So now I need the inverse derivative at 1, so I just plug this in. 2 times 1 gives me 2. Now I need the inverse derivative at 9. 2 times 9 gives me 18, and I'm done. Pretty easy, not too bad. Let's try method 2. Let's change the pen color here. And in method 2, this is going to be the formula. Now, some of you may say, why do the formula? Why do the formula? You'll see that, method 2, that the formula will come in handy sometimes when we can't separate out. Over here, I was able to solve for y. If you get a situation where you can't do that, then the formula, that's where it comes in handy. So let's take a look. The formula says I need the derivative right here, right? So f prime of x will give me 1/2 x to the negative 1/2, negative 1/2, and I'm going to rewrite this as 1 over 2 root x. The formula also says I need the inverse value at a. So the inverse value over here is what I'm solving for again, but I already did that over here, and I solved for it completely, so I'm just going to write in what I solved for completely. So now I need the inverse at 1. So the inverse at 1 means I'm going to plug this in, I'm going to get 1. I need the inverse at 9, and I'm going to plug this in and I get 81. So now the formula says the inverse value, the derivative at a, is going to be 1 over f prime. Now, I found my, we'll go ahead and write it in, and then I'll tell you what I found. I found my f inverse of 1 right here. So let's do this first part. F inverse of 1, I'm going to change the color again on you. Okay, so f inverse, so this is going to give me, when I put in 1, this will give me 1 over f prime of 1, right? I put in 1, I got out 1. Okay, I take the derivative over here, and I'll get 1 over 2 times square root of 1, which is 1/2. So 1 over 1/2, which is 2. Now I'll do the same thing, but this time I'll use the 9, 1 over f prime of 9, right? F prime of, or f inverse of 9 gave me 81, so I'm taking 1 over f prime of 81. That's how I should say it. So when I put in 81 here, I'll get the square root, which is 9 times 2 is 18. So I'll get 1 over 18, and that gives me 18. Again, the direct method way could be easier, but you may not always be able to do it that way. We're going to end up with a problem. You'll see that you cannot do it that way. All right, let's take a look at this next one. Here's another type of situation you're going to come across. On this next one, it says, if f of x equals x to the fifth plus x cubed plus 2x minus 2, find the inverse derivative at 4. Okay. If I try to take the inverse here, I will switch the x and the y, whoops, and that will give me x equals y to the fifth plus y cubed plus 2y minus 2. All right, trying to solve this for y, I can't. And because I can't, I cannot do what I did here where I solved it for y, then automatically took the derivative. Okay, so I do need to end up using that formula. And in that formula, I still need other things. I still need a derivative. So let's find f prime of x, and that gives me 5x to the fourth plus 3x squared plus 2. Now, the formula right here, I'm not going to keep writing it because you guys have it multiple times, says the inverse derivative at a is 1 over the derivative, and I have to find the inverse at a. So the key right now is to find the inverse at a. So my a value in this problem is right there. So a equals 4. So that means when x is 4, so 4 equals y to the fifth plus y cubed plus 2y minus 2. Again, I can't solve this for y. We're going to use our calculators. So on your calculator, you're going to set this like this, bring the 4 over, y cubed plus 2y minus 6. You're going to graph it. And when you graph it, you're going to pretend that these y's are x's, and you're going to get a function that looks something like this, and it crosses right there, and you'll find that root, and that's 1.1612. Okay? So that's what the y value is. Because remember, you graphed it pretending it was an x, but that's actually what the y value is. Which basically means that's what our inverse is. So now I need 1 over f prime of 1.1612, right? Because I got this part, f inverse derivative of 4 will equal, I got this part right here. I found the inverse at that value. This was it. That's how I did it. Now I need the derivative of that from my derivative. So 1 over, plug this in to here, 1.1612, right? And you'll end up with 15.14. Again, what you did was 5 times 1.1612 to the fourth plus 3 times 1.1612 squared plus 2, right? And that's what you get. So breaking this down, this becomes 1 divided by that was 0.06604. So now we're going to go ahead and do one more problem, and let's take a look at it. And here it is. It's number 3. It says, let f be the function defined by f of x equals that, and g of x equals the inverse. Oh, so g of x right here, they're telling us equals the inverse, and g of 2, so the inverse at 2 is 1. What is the value of the derivative of the inverse? So they're giving us that f of x is that. We know that g of 2 equals 1, and that this is the derivative of it. I'm going to change my pen color like I always do. So we know that these two, and it's the inverse. So g of 2 is the inverse. So this just means that the inverse at 2 is equal to 1. So that's what that's telling us. And we're going to go ahead and use our formula to determine what this is. Because I don't have, again, if I switch the x and y, I won't be able to solve it. So basically, we have our formula, which is the inverse derivative, right, at x is going to be 1 over the derivative, and then I need to find what this inverse value at x would be. Okay, so let's first work on finding the derivative. So over here, f prime of x is going to be 3x squared plus 1. Now, they're telling me that at this value, g of 2, I get 1. So the inverse of 2 is 1. So basically, I already know that it's 1, and that's what I'm plugging in here. So I need 1 over f prime of 1. Because again, I know that g of 2 is 1, and I know that g of 2 is the inverse of 2. So the inverse of 2, here's the 2, 2, 2. The inverse of 2 equals 1. So the inverse of 2 equals 1, and that's what I want to take the derivative of. So the derivative over here, f prime of 1, becomes 3 times 1 plus 1, which is 4. So 1 over 4 is my final answer. All right. Hopefully this lesson wasn't too bad. Just take a look at the examples. We'll do more in class. So thanks for watching. Hit that like and subscribe button, and I'll see you guys in the next video.